On this video, we're going to talk about linked list traversal. So we've looked at adding something to the list. We've looked at removing something from the list. Okay, beyond those two things, really the most fundamental other thing you need to do in a list is to walk the list or traverse the list. And what that means is you start at the head and you visit everything in the list all the way up to the tail or some part of the list. Traversal is so important because we need it for lots of different things we want to do to a list. Like if we want to check if something's in my list, like have I put milk on my list? Then I need to go through every item in the list and look to see, is it milk, right? So to check for existence of an item in my list, I need to traverse it and walk through everything in the list. To determine where I might want to insert a new item, I might need to look through the list to find an item, right? And the only way I can find it is by looping through it. If I want to know if something needs to be removed from the list, I might have to look through to find the matching thing that I want to remove, right? And then to make a copy of the list, I would need to, and this might be important in a copy constructor or assignment operator, I would need to visit each thing in the list and then move it into another list or copy it into another list. So traversal is just something we're going to have to be able to do on the list, right? Okay, so how does traversal work? Well, we're going to want to start at the head and work our way to the tail. And so at the very beginning, I could pretend like I have, this temporary variable set to head. And so after I get the list object and I copy head into a temporary, then the temp is kind of sitting off here to the side. It's not part of my list object. It's a local variable in a function. And so, I'm just going to draw it here as something kind of floating off above the list. And so temp is pointing to the first list node that's holding milk here. This is the head of the list, and it's pointing to the same node that head is pointing to. Okay, if I want to move this to the next node in the list, then there's a simple way I can do that. I can just say temp equals temp next, right? So temp is this node. If I follow temp arrow next, it takes me to this node over here. And so by saying temp equals temp arrow next, I'm modifying the temp variable to point at the same thing its next pointer points to, right? And so visually, I go from pointing to milk to pointing to eggs, right? By executing that code one time. Okay, I could execute this code multiple times, right? So after when I first set temp equal to head, it's pointing to milk. If I say temp equals temp next one time, I go to eggs, right? Because I just follow the next pointer. Then if I say temp equals temp next a third, again, so this is the third step, then I follow the next pointer from eggs to bread, and so now temp is pointing to bread. And then if I do this one more time, I'm going to follow the next pointer from bread to null, and now temp is pointing to null. Now that I've updated temp all the way to point to null, I had better stop and not execute this code again. If I try to use the arrow operator on a null pointer, I'm going to get a segmentation fault, right? The system is going to say you're not allowed to access address 0. This is an error. It'll stop me. So when I think about traversal code, I'm going to start at the head. I can advance to the next location by saying temp equals temp arrow next. But then, and I can keep doing that as long as there's a next node to go to in my list. But as soon as I get to the end of the list, where I have that null, I need to stop the traversal. And so this leads to some code that looks like this, right? I initialize temp to be head because that's the beginning of my list. And then while temp does not equal null pointer, I can loop, right? As long as that temp doesn't become null, I'm not at the end of the list and I can loop. And each time I go around this loop, I advance my pointer one node, right? So temp equals temp arrow next. That moves me down one node. And then, in the body of this loop, what I could do then is, since I have this pointer temp pointing to that node, then I could get the data out of it and I could do an operation on it if I need to. Okay, so in summary, traversal on a linked list occurs in forward order because the next pointers only point in the forward direction. We have to terminate traversal when we reach a null pointer, because if we were to try to keep going, it would lead to a fault and a failure. So we have to catch that termination condition precisely. Traversal, again, is important for many tasks like sorting, searching, copying, etc. This just basic loop, you need to get really comfortable with the ability to write that traversal loop. You should just be able to write it without thinking hardly. Because it's not only going to be valuable for lists, it's going to be valuable in a lot of other data structure implementations we're going to see. Now, a question you might think about, and I'm not going to tell you the answer right now, is it possible to start at the tail and go to the head on this list implementation? Can we do that? And another question, is it possible to start going forward, right, down the list, but then stop and go in reverse? Can we do that? Can you come up with a way of making that work on this list object that we've defined so far? Think about that. Think about what you think the answer is, and it may get answered. It may get answered for you in an upcoming video, and it may not, but I promise we'll get to it eventually.